Hello, my name is Brian Gonzalez, and here at Channel 5, today's topic is the collision theory. I'm here with Deanna Martinez, a chemist at Reptar Corporation.
Hello, Brian.
So we can get a better understanding of the collision theory, I'm going to ask you a couple of questions, Deanna.
Alright, then let's start.
First question, so what exactly is the collision theory?
Well, the collision theory basically just states that atoms, ions, and molecules have to collide in order to react.
Next question, what is needed to form a successful collision?
First, the substances must collide. Second, they must collide with correct orientation. And third, they must collide with enough energy to form the activated complex.
Third question, Deanna, what's the activated complex?
The activated complex is a temporary unstable arrangement of atoms that may form products or break apart to form reactants.
Final question, Deanna, so what's next after that?
Well, the energy that the reacting particles must have to form the activated complex leads to a reaction called the activation energy. Also, the activation energy has direct influence on the rate of the reaction. For example, if there is a high activation energy, that means that there were few collisions to produce the activated complex. So the reaction rate would be low. And if there is a low activation energy, then that means that many collisions and a higher reaction rate.
Well, I'm sure we learned a lot about the collision theory because I know I did. Thank you for letting me interview you, Deanna. And that's the show for Channel 5. Have a good day. Today's experiment, we are going to be making elephant toothpaste to see how the collision theory is used in the experiment by the addition of a catalyst influence to affect the rate of reaction.
These are the materials we will be using for our experiment. A 1-liter bottle, 80 milliliters of hydrogen peroxide, and 5 squirts of dishwater soap, and 25 milliliters of potassium iodide.
And since we are going to be using glassware, we will wear goggles just like Ms. Stewart tells us to.
Because the normal decomposition of hydrogen peroxide in its aqueous solution happens very slowly, today we will be using a catalyst. To speed things up, we will be using the potassium iodide.
Now we will pour 8 milliliters of 3% hydrogen peroxide.
And then we will pour the potassium iodide. Oh yeah, the dishwater.
But first, before we do that, we will be putting 5 squirts of dishwater soap.
Is that good?
And now we will add the 10 milliliters of potassium iodide.
I know 15 minutes could save you 15% or more on car insurance.